What's up, Trig? This is Mr. Carlson, C Squared Mathematics. Welcome back to another exciting video. This is the second to last lesson of the entire course, and we are going to go through 7.6 vectors. So now we've kind of been dabbling just a tad bit with vectors over the last couple of weeks and then definitely yesterday. And so it is going to be kind of going through and dipping into the waters of physics these next couple days. So I hope you can stick with me just a tad bit. We're going to go through bell work. I have 2 questions on the bell work to prepare you for the homework quiz, and then central question, objective, and then the actual lesson. Now, most of this lesson will be just basic foundations regarding vectors. It's not going to get too intense with the vectors here, but towards the end, there will be a couple of problems that can get a little sticky, okay, a little gummy in the mathematics. So without further ado, let's get started. These are the 2 questions I have for you. We want to write the complex number in rectangular form. So that simply just means we're going to evaluate it. And then here we're going to leave answers in polar form, but we're going to find the product. So go ahead, pause the video if you need to get these answers or these questions down, and then we'll get started. All right. Right here, I just want to evaluate. So I want to evaluate cosine of 240 and then sine of 240. So this will equal 3. And then cosine of 240, all I have to do is just use my unit circle for that. And just the x-coordinate at 240 is -1/2. So this is -1/2 plus I. And then sine of 240 is going to be, I'm going to put this in parentheses, negative radical 3 all over 2. Okay, when I simplify this, I multiply through, so this is -3/2, and then this is plus, and then this right here is going to be -3i times radical 3 all over 2. So this is my rectangular form, and I know it kind of looks nasty, but this is plausibly the best thing that you can do. This is the only way that you can simplify it. There's no other way that you can perhaps simplify it as such. It is what it is. And so, looks pretty nasty. I get that, yes, but that's my answer. For 2, I have two polar complex numbers in polar form. So I have z1 and then z2, and I want to combine these. Now remember, this is my theta 1, this is my theta 1, this is my theta 2, and this is my theta 2. Now I want to find the product, which means I just need to add. So what this will be, and I'll do it over here, z1 times z2, this will equal, now what's my r, you say? My r is just 1 in both cases. So maybe that would confuse you, but in both cases, my r is 1. It would be out here, just right there. But since we don't have any parentheses to start with, that tells me my r is 1 in both complex numbers in polar form. So I don't really need to multiply anything there. It's just 1 times 1. So how do I solve this? This is just cosine. And then I take pi all over 6 plus pi all over 3. Now the reason why I do that is because it's product. And product means plus here in this context. All right, I would multiply my r's together out front, but I don't have r's besides 1, so it's just 1 times 1. So that's that, and then plus I, and then sine, and then the exact same thing. So pi all over 6 plus pi all over 3. So that's essentially what that is 30 degrees plus 60 degrees, which is just going to be 90 degrees. So I have cosine of pi all over 2, and then plus I sine of pi all over 2. Now this is all they want because they do want it in polar complex form. So this is my polar form here. If I wanted to go further and put it in rectangular form, I could evaluate it, but and I'll show you that right now, but this is my final answer total. If I wanted to go further and evaluate it to be rectangular form, I could. Cosine of pi of all over 2 is the same thing as 0 when I evaluate it, and then this is I, and then sine of pi over 2 is just 1. So my rectangular form is literally just 0 plus I, or in this case, it would just be I. This is what it is in rectangular form. Okay? But like I said, all they wanted was polar form. So make sure you kind of understand the difference and kind of relate the difference between polar and rectangular form. It is can get sometimes tricky there. All right, that's all I have for bell work. Let's get started on the homework quiz, and then we'll get to 7.6, vectors. I remember learning vectors for the first time. It wasn't that great. 7.5, homework quiz, open notes, of course. If you have any questions, let me know. If you have any partial credits, then let me know. Okay, get started on it if you want to. 7.6, now vectors. What is a vector and how do I use them to solve problems? I'm going to answer the first question primarily throughout the lesson, but this last question, how do I use them to solve problems, is a very sticky question. It's very physics involved, okay? And so I've always said, and it's totally true, that if science and math have a baby, you get physics. It's just what it is. And oftentimes physics uses higher level mathematics, such as trigonometry. And so I'm going to kind of show you some of those application questions, specifically just one primary question, but I will show you other questions as well. So at the end of the lesson, you should be able to recognize vector quantities and then what a magnitude and direction is by performing vector operations. So let's go through the basics, the very basics of a vector. What is it in a general form? Well, it's AI plus BJ. You can say xi plus yj. It doesn't really matter. You can label it however you want, but I'm using I and j because those are the basic vector notations there, and then a and b because it's similar to complex numbers. However, I have to make a note later about this, so I'll come back to this and make a note about that. What are some parts of the vector? Well, there's two primary parts. The first part is magnitude and length, and I'm going to show you what that definition is in a bit and what that formula is. And then the second part is the direction, or what we call the slope or angle measure with the terminal side on the x or y axis. So just like complex numbers, you have a real axis and then the imaginary axis. In vectors, you'll have an y-axis and then the j-axis, just like x and then a y-axis. So it's very similar to your real axis and then your complex number axis. Just like what I said, vectors on the ij plane instead of xy. So we're going to learn how to plot vectors soon in a little bit. I'm going to plot that in a bit. And then we're going to learn what position vectors are. Okay, what are position vectors? If I have 2 points, 2 single points, what is the position vector? So I'm going to graph it, and then we're going to actually do the math, the algebra, in a bit, because this is technically just algebra. We're going to learn what equal vectors are. It's basically just the same magnitude and length. Those are very rare in life, to be honest, and then the same direction, same slope, and angle measure. Again, very rare in life. It's very difficult to get an actual equal vector. Now, let's go back through these. General form. What is the general form? Well, this I right here, notice this I. This is not an imaginary I. I want to be emphatically clear about that. It's not imaginary at all. It's its own entity. So it's its own variable. Ij is a vector notation, okay? So don't think of it as an imaginary I. It's not complex system at all. It's not in the complex system. It is technically in the real system, but it's modified. Like the XY plane is going to be modified for these notations. Okay? And this is the formula for magnitude, or what we call the length. So I use double bars right here. You'll see that often. And then V is, that's how I name a vector. So vector V, it's kind of bolded there. So when this is technically saying the magnitude of vector V equals the square root of a squared plus b squared. Now that should look very familiar to you. That is straight up my Pythagorean theorem, of course. Okay, so it's all going back again to the Pythagorean theorem, which is amazing, right? I love that. And then let's actually get into plotting these vectors. So this is going to be my j-axis, and this is going to be my I-axis. All right, my j-axis and my I-axis. How do I plot negative 3i plus 4j? So negative 3i, so this is negative 3, and then plus 4j. So this is 4. And so I plot it right here. And it's as simple as that. So what this is, guys, is this is what we call a vector. I mean, I know I didn't really do that well, but this is what we call a vector. And we've already been doing these. And so you're probably thinking like, this looks very familiar because we've been doing this since like unit 1, honestly, with 5.4, 5.3. We've been doing this all the time. These are vectors, okay, which is really cool. And if you think about it. Now, position vectors, I can plot that like -5 or -2, 5. So -2, 5. What are position vectors? So -2, 5 is going to be right here in blue. And then 1, -1. So 1, -1 is right here. So essentially, these vectors, that would be like a vector. This would be a vector. And if I want to find the resultant vector, which we will get into a little bit, but those are position vectors. If I want to add those or anything like that, if I wanted to find the resultant vector, I would go do something like this. Now that is definitely a triangle, okay? And that's an oblique triangle. And what we can do is find the angle between the vectors, just like using law of sines and cosines. We're not going to do that during this lesson, during our trigonometry, but in physics you would. In upper level physics you would, not here at MHP. But you could do that. And then this resultant vector we will actually find. We won't find the angle in between. Well, we will find the angle in between these two vectors, but we won't solve like the whole triangle, is what I'm saying. And we would find this vector, what we call the resultant vector. Very interesting stuff, okay? So that's basically how you plot them. I'm not going to go into depth anymore with plotting them because it's very standard. You plot them exactly how you would just a normal XY plane point. And that's pretty much it. You would plot them exactly how you would a normal XY plane point because it is a rectangular form, just like complex numbers. So vectors in rectangular coordinates. So if I am given this vector v with initial point this and a terminal point is equal to the position vector this. Okay, so this is equal to that. And so when I have 2 points, it's very, very similar. It almost looks like a distance formula in a sense because of x2 minus x1, like kind of like slope and stuff like that. And they are very, very similar in that way. So let's kind of see what's happening here. If I want to find this position vector v, all I have to do, let's just say, is take this is x2, this is x1, this is y1, and this is y2. I take 9 and then minus a -5, and this is I. Plus y2 would be 3 minus a -7, and this is j. Okay, that's all it is. And now I'd simplify this out, so this would be 14i and then plus 10j. This would be my position vector. Okay, basically adding them. So write your vector in terms of I and j. Well, then there you go. If I'm given 2 points, I can find a vector between those 2 points. Okay, those 2 points, and then that's what it is. So given those 2 points, that's the vector that goes through them. All right, sounds pretty good. Very simple stuff indeed. I could also find I can also do other vector operations. So let me erase this and let's go to what we call scalar multiplication. Scalar multiplication is very simple. You're just multiplying it by some number. So if I have vector v equals ai and then plus bj, and k is what we call a real number, k is my scalar, then the scalar multiplication of the vector is a vector v, and the scalar k is just as follows. So what will that look like? If I'm asked to find vector, -3v, what that means is this 3, this -3, that's my k value there. So if I want to find this out, what I would do is take -3v. If I want to find that out, I would take -3 times my a, which my a is -8, because this right here is your a, this right here is your b, and then this is I plus, and then negative 3, and then times negative 7. For my j. So I just basically multiply that negative 3 to both of my terms. So basically like distributing it out. I mean, that's really what it is. You can rewrite this in just saying k and then ai plus bj. You can really write it that way if you wanted to. And you're just distributing it out. That's it. So basically you're just blowing it up, making it bigger. So what does this equal? This equals 24i and then plus 21j. All right. So that is my blown up or scaled vector. Let's do another one here. What if I want to find vector negative 4v? Okay, so vector times a negative 4. So negative 4v equals, and again, I just take negative 4 and I multiply it accordingly. So I really just multiply negative 4 to my whole vector, but I just simplify it out. So this is 16i, and then this is just going to be plus 8j. So think of it as almost like this distribution. You're distributing this vector here. You're distributing it through. Nothing different. It's just distribution, okay? Very simple stuff. That's scalar multiplication. Isn't that awesome? Again, you like Unit 3, don't you? This kind of stuff in Unit 3 is way easier than Unit 2. Not too difficult at all. Okay, I can add and subtract them as well. So the properties are very, very similar indeed. You're just adding your A and B and adding your, or subtracting your A and B. So let's go through an example. If you need to pause the screen, sorry, my bad. If you need to pause the screen so you can get those down, please do so. Let's get started. Because I'm going to use these formulas. So if I'm given these two vectors, vector v and then vector w, I can add them, right? If I really want to add them, let's find Let's find v plus w. I also want to find w minus v, but I also want to find 2w plus 3v. So it's a lot of stuff happening here. Okay, so let's go to town. So this equals, I add them together. So essentially I'm just adding like terms. I mean, that's honestly, that's essentially what I'm doing. I'm taking 3 minus 2, following my formula from the last slide, I, and then plus 4 plus 1, and then j. This is 4 plus 1j. This equals I, and then plus 5j. Notice my i's, I'm not usually doing a curly tail on them because that's how I do my imaginary. So my imaginary numbers, that's how I do it. I just want to let you guys know that's how I write it. And so that's my imaginary numbers, but I just means like vector. So I learned how to do that in college because I kind of, when I had to do imaginary numbers with vectors, I kind of got confused. And so for me, my straight I is a vector and then my curly I is imaginary. So maybe you want to adopt that as well. But that's how you do it. That's how you add them. If I want to subtract them, what I would do is now do W minus V. Okay, so this, in this case, it would be negative 2 minus 3. And then I plus, and then 1 minus 4. Okay, and then J. If you're wondering why, that looks awful. If you're wondering why I subtracted on the first one right here, on this one, is because it's 3 minus 2. So that would be 3 plus a negative 2. I'm still adding either way, but I'm using my negatives because I'm adding because it's plus. But I'm using my negatives accordingly because it's 3 plus a negative 2 and then 4 plus 1. Here it's minus, so that's why I have minus signs in the middle. So just wanted to let you know that in case you got confused. This is J. So this is going to be negative 5I and then minus 3J. Awesome. Now here, the first step I would want to do is just multiply and find your 2W. That's what I want to find. I want to find 2w. So when I'm multiplying 2w, what I get is I just multiply this whole thing. So that's going to be negative 4i and then plus 2j. Okay, negative 4i plus 2j. That's what I get. My second step is to find 3v. So 3v equals, I'm just multiplying 3 to everything. So that's going to be 9i plus 12j. And then all together, if I want to find 2w plus 3v, notice how I'm breaking this apart. Now I'm just using this and then plus that. So when I add them, that's going to be 5i, because 9, when I'm just adding them, I'm literally just taking negative 4 plus 9, which is 5. And then this is going to be plus 2 plus 12 is just 14. So 14j. Okay? And that is my final answer. Sweet. So that's how I add and subtract them, mixed in with some scalar there. Let's focus now on magnitudes. What is a magnitude? Again, and then how can I simplify it? How can I solve for it? So magnitude, that's my formula. Given these two vectors, again, I'm going to be primarily using these two vectors simultaneously in the next couple of slides. So I'm going to be using these two vectors. I want to find the magnitude of each, and then I want to kind of compare. So I want to find the magnitude of v. I want to find the magnitude of w, magnitude of negative 2w, and then I also want to find the magnitude of v minus w. So a lot of stuff is happening here. So let's just take it one step at a time. What is the magnitude of v? Well, this is going to be the absolute value. Well, it is the absolute value because r is the absolute value of, it will always be positive no matter what. It's just your r. Your r is the same thing as your magnitude and the same thing as this. If you really want to get technical, these are all literally the exact same thing because they all equal this. But your magnitude, to not get too sidetracked, your magnitude of v is your a squared plus b squared. So I'm looking at v here. So this is going to be 3 squared plus 4 squared. Now, again, it doesn't take a genius for you to know that this is just going to be 5. Okay, it's a 3, 4, 5 triangle. Okay, 9 plus 16 is 25. Radical 25 is 5. Now, with your magnitude w, with magnitude w, it's a little bit different. So this is going to be negative 2 squared, which is 4, and then 1 squared, which is just 1. So this is going to be radical 5. So that's your magnitude. Again, these are like your r's or your hypotenuses. Okay, these are like your c squareds. Okay, that's essentially what it is, or your c's, your hypotenuse. Now, negative 2w. We already know what negative 2w is. Remember, when we did positive 2w. So I'm going to first find negative 2w. So let's just do it down here. So negative 2w. When I multiply everything to that, that's going to be positive 4 and then plus positive 4i and then actually minus 2j. So that's negative 2w, positive 4i. When I multiply negative 2 to everything, positive 4, negative 2 minus j. So I'm going to use that to find my magnitude. So 4 squared, and then this is going to be plus a negative 2 squared. So this equals radical 16 and then plus 4. This equals radical 20, which simplifies down to 2 radical 5. Okay? Because there's a 4 in there, 4 times 5. 4 is a perfect square. It comes out as a 2. Radical 5 is left over. V minus W. Now, when I do this, all I really have to do, guys, is look right here. I already found the magnitude of V. I already found the magnitude of W. So I just need to take 5 minus radical 5. And that's all I need to do. I already found the magnitude of V. I already found the magnitude of W. Now I just need to subtract them. So essentially what this could be rendered as is this. magnitude of V minus the magnitude of W. And that equals this. So you can simplify that and rewrite it to be this, so that you can get your final answer, if that helps you. You don't need to subtract these two together to get this, okay? You just don't need that to be the case. Awesome. Let's erase. Let's go on to unit vectors. This is a big topic in today's lesson. Pretty big topic, unit vectors. What it is it's essentially just the same direction of a given vector. So with a magnitude equal to 1. So it's the same direction, but the magnitude is just equal to 1, okay? So that's essentially like sine squared plus cosine squared equals 1, okay? So sine squared plus cosine squared equals 1. That's almost exactly the same as a unit vector. Okay, so given the vectors v and w, find the unit vector of each. So I'm going to put our vectors down. We're going to be utilizing these again. And here is the formula. So it is sine squared plus cosine squared equals 1 because you're going to use the Pythagorean theorem. The magnitude is this. So if this is the case, then the vector v is non-zero. So it can't be 0. And the vector u equals v all over the magnitude of v, okay, is a unit vector that has the same direction. So what's my formula? Well, this is my formula right here. I'm not going to get into how I go from here to here. There is a nice little formula of how I go to here, but I'm not going to get into that. But just know that this is my unit vector formula. So let's find the unit vectors. Let's start with 1, and then we'll go to 2. So 1, 3i plus 4j. So my unit vector of v, so I'm going to say u of v. Okay, u of v. My unit vector of v. Wow, that looks still really junky. Okay, unit vector of v. This equals my vector v. So I'm literally going to implant all of that into my numerator. So my vector v all over my magnitude of v. So we already found the magnitude of v in the last slide, and that was 5. So then I simplify this out. This is 3i all over 5 plus 4j all over 5. Okay? So very simple, not too difficult. Let's go to 2. And so I'm going to find my unit vector now of w. My whole vector, w, gets placed in the numerator. So that means negative 2i and then plus j all over the magnitude of that vector. So the magnitude of w is just simply radical 5. That's what we got in our last slide. So in order to do this, I do need to rationalize. I can't leave the radical in the bottom here. So let me rationalize. This is negative 2i and then radical 5, then plus j, radical 5. And then this is all over just 5. So if I wanted to simplify this even more, to split it up in my ij form, this is negative 2i radical 5 all over 5 plus, and then this is j radical 5 all over 5. So that is my final answer. So unit vectors are a pretty big thing, and you're going to see it all scattered throughout your homework as well. So, but they're not too difficult. They're actually very straightforward, and we're going to be using magnitudes and unit vectors a lot throughout the lesson, specifically in the next slide. So far, that was the basic overview of vectors. I haven't really gone too much into depth with the vectors here. This is the base foundation for any class that you would learn. You would learn just this stuff. However, because we're in trigonometry, we need to relate it somehow to trig, right? And that's what we're going to be doing now. So you may be thinking, yeah, this is great, but so far this is all technically algebra. Let's see how it's related to trig. So writing vectors using trig ratios, I'm going to use that formula. So let your vector v be a non-zero vector, so it just can't be 0, it needs to be something. And theta is the direction angle measured from the positive x-axis. Then the vector can be expressed in terms of this. Now, I don't really like using this formula. I'm going to use a separate formula. I'm actually going to use this one where my v equals the magnitude of v times cosine of theta I, and then plus sine of theta j. Okay, so this is the formula I'm primarily going to use, and the only reason why I like doing that is because it's just easier. Like it's basically the factored form of this. I'm basically factoring out your magnitude of v here. That's all I'm doing. You're factoring out the magnitude of v. And it's just a lot simpler to use and easier to simplify, specifically when I go through problems like this. So I'm going to show you my vector v. What does vector v equal? How can I write this vector in terms of trig ratios? And basically using trig ratios and then getting to the actual vector. So in other words, if I'm given a magnitude and a direction, how can I use that magnitude and direction and write it into a vector? Well, I kind of have to first put it in this form, and then after that form, I evaluate it so it can be in rectangular form. Sound familiar? So I need to go from given a couple things, the direction and the magnitude, because this is the magnitude and direction. Remember vector from Despicable Me, both magnitude and direction, and then he does his like gyrating move, like, oh yeah, from Despicable Me. It's very, very obnoxiously catchy. So magnitude and direction, given those two things, I'm going to put them into a trig ratio, okay, in almost polar form, but vector polar form. And then I'm going to take that and then translate it to rectangular form, just kind of like what we did yesterday. It's almost very similar, but now with vectors. All right, but I'm going to be using this formula here. So what is my magnitude of v? It's 6, and then I'm going to have cosine of theta, which is 135 degrees, and then this is I, and then plus sine of theta, which is 135 degrees, and this is j. Now, if you want to put your I and j's out front in front of your cosines, that's fine. That's completely fine. Sometimes I do that, sometimes I don't. It really just depends. But just notice that your I and your j are not part of your angle measure. So if you want to put parentheses around there, you can. They're just not part of your angle measure. If you want to put them out front, be my guest. I do not care. So this is 6 cosine of 135 using the unit circle. So using the unit circle is negative radical 2 all over 2. This is I. And then this is just going to be positive radical 2 all over 2 because it's in your quadrant 2, and only sine is positive in quadrant 2. So don't forget your I and j's here. And so what is vector v? Vector v is, when you distribute it out, this is going to be negative 3 radical 2, and then I, and then plus, this is going to be 3 radical 2 j. Again, you can put your i's and your j's in front of, or like basically say negative 3i times radical 2 plus 3j times radical 2. It's just a little bit different. Like for me, with vectors, I always usually try to give like a little small space here and then do my I and j afterwards. Because it's a vector, and I don't know, maybe I got used to just doing that over the time, but yeah, I don't know. This is how I write it. So if you don't like how I write it, then you can figure out a different way as long as you get the right answer. Okay? Awesome. Let's get started. So that is the majority, I think, of the lesson that you probably will see on Math Excel. That's probably the majority. Now let's get to a couple of application questions. So let's erase this. And then I have 2 slides of application questions. So on this next slide, I have 2 examples that we kind of deal a little bit with work and then also force. And the next slide is going to be really, really big. So let's go through this one. A vector is described, express the vector in terms of I and J. So a quarterback releases a football with a speed of 37 feet per second and an angle of 45 degrees. So this automatically should tell you your magnitude. Your magnitude is 37 and then feet per second. Okay, your directional angle is just 45 degrees. All right, so you both have the magnitude and then the direction. You want to find the vector in terms of I and J. So we literally just use exactly what we did in the last slide when we translate it to a kind of a quasi-polar form for trigonometric equations, okay? Quasi-polar form from trigonometric equations, that's what we're going to do. So V equals, using my formula, I have 37, and then I have cosine of 45 degrees, and then I, and then plus, this is sine of 45 degrees, and then J, okay? What this equals is 37, and then cosine of 45 degrees is just radical 2 all over 2. This is I, and then same thing for sine. So I'm just going to write that. And then all together I have 37, 37 radical 2 all over 2, I. And then this is plus 37. Sorry, I'm like, it's being really, really slow. Radical 2 all over 2, and then J. So this one's very basic, not too complicated, because they pretty much give you your magnitude and direction at the very beginning. Okay? Sweet. Let's go to the next one. Very similar. Plane flying downward on a runway, 153 miles per hour with an angle of 4 degrees. So I'm going to use 153 miles per hour. That is my magnitude. That's like that's essentially just my magnitude, my distance almost. So this is V. I want to find my vector in terms of I and J. So 153. I have cosine of 4 degrees I plus sine of 4 degrees J. Okay. Now this is kind of interesting because obviously it's not on the unit circle, so you do need to actually calculate this on your calculator. You can do it on Desmos using just degrees. Make sure you're in degrees. Make sure you're in degrees, or your TI-36X Pro. Make sure you are in degrees. I'm just going to give it to you right at the beginning. So this is 153. What is cosine of 4 degrees? That is 0.9976 I. And then sine of 4 degrees is 0.0697, and then J. And then when I multiply all that through, just multiply it, distribute that through, you're going to get 152.63 I, and then plus 10.67 J. I know it's kind of odd here. Very interesting vector, because vectors in real life aren't as pretty as a 45-degree angle, right? So some of these vectors can get really nasty, as we will see in the next slide. So the next slide is going to be probably something on your tests. I'm just going to say that right now, and it's very long. And so I'll probably spend the majority of, I don't even know how much time we've spent on this video, but I'll probably spend the majority of this time on the rest of the time on the next slide. So let's go to it. So this is our next example. So pause the screen if you need to. I would copy this down so you at least have it. The magnitude and direction. So yeah, we'll probably spend the next 10 minutes on this question because it's at 40 degrees, 40 minutes. 40 minutes right now. So the magnitude and direction exerted by two tugboats towing a ship are 1620 kilograms, so 1,620 kilograms, at a bearing of north 30 degrees west, and 120 or of 1,280 kilograms on a bearing south 50 degrees west, respectively. So what does that mean? That means you have two tugboats. So let's just say I am the ship that they're carrying. The tugboats are like carrying me. Okay, that's kind of what they're doing. So If I wanted to draw a basic picture here, I'll erase it, but this is essentially what they're doing. So you have a ship, and then there's a tugboat and another tugboat. So this is like tugboat 1, and this is tugboat 2, and they're going in that direction. So they're kind of in the waters, they're kind of tugging that tugboat that way, or whatever way. But the problem is, this tugboat is on a different bearing, obviously, than that tugboat. Okay, so they're on two different bearings and they're tugging it different ways, and yet it's still pulling the ship forward. So essentially, maybe you can think of it like you and your dad or you and your brother or whatever are pulling something together. Okay, so you're pulling it together because it's really, really heavy. Okay, that would be an instance of that. Or let's just say you have a dead body, you know, God forbid you have a dead body on you, but you have a dead body, you need to get rid of the body. So your brother or whatever holds one arm of the dead body, and then you hold the other arm of the dead body, and you're tugging the dead body. You're both tugging it in, yes, a similar direction, but they have different bearings. That's the purpose of this question. Okay, kind of an odd example, but I think it still suffices. So how do I go and do this question? Great question. First things first, I want to write out what I want to find. I want to find what a couple things. Actually, let's find this. Let's label what we have. We're given two forces. So I'm going to give two forces. Force 1 is 1620. Okay, and then force 2 is 1280. All right. Now I'm given two angle measures using bearings. I'm given two angle measures using bearings. So angle measure 1 and angle measure 2. Now I don't know what the actual angle measure is until I actually calculate the bearing. So I need this information in order to solve for the vector. Because right now I need to take this and plug it into vector form. That's the issue. It's not in vectored form right now. I need to take my magnitude and I need to find my directional angle. I have a magnitude, sort of, and then I need to find my, well, I do have a magnitude right here for each individual tugboat. This is tugboat 1, this is tugboat 2. I have my magnitude. I need to find my directional angle of that tugboat. Okay? But I'm given that directional angle using bearings. So I need to find the exact angle measure, the exact directional angle for that tugboat, so that I can then add them. So basically what I'm going to find is the vector. After I find that directional angle using the bearings, I then need to plug this into my formula that I just found 2 slides ago, so I can find my vector. I can do the same thing here using bearings, find my directional angle, plug it into the formula that we had 2 slides ago, so I can find my vector. I'm then going to add those vectors. Why? Because I want to find the magnitude in kilograms and the directional angle of the resultant force that's adding them. So I need to find the vector here after I find my directional angle, find the vector here after I find the directional angle. Then I have those two vectors, and then I need to add those two vectors and then find the magnitude and the directional angle of that those combined vectors. So as you can tell, is it a long problem? Yeah, it's a very, very long problem, but it's a glorious problem, and it's totally applicable of what math, like the gloriousness of math and what we can use it for. So first step, what am I going to do? I'm going to write down a formula. V equals actually, you know what? I'm going to save room here, and I'm actually just going to write this formula up here. So this is my general formula for writing it in trig functions. So I have cosine of theta I, and then plus sine of theta j. So this is my basic formula that I'm going to be utilizing over and over and over again. I need to use this formula in order to translate this into vector form. Okay, this is an important formula that I need to use in order to translate my problem into vector form. Okay, so first things first, let's find the bearings. I need to know what the bearings are. So let's go to the first one right here. North 30 degrees west. So that right here is going to be in quadrant 2. So north 30 degrees west. So it's going to look something like this. So this is my north, this is my west, this is 30 degrees. Now the problem is, what's the actual angle? Okay, what's the whole angle here? Well, the whole angle is this, right? So I literally just take 30 degrees plus 90 degrees, and so this whole angle is 120. So I'm going to go over here, and on my first force, my first vector that I'm trying to find, it's 120 degrees. Sounds good? Okay. I know it's 120 degrees because that's 90 degrees plus another 30. That's 120. Awesome. So I know that's theta 1. Now I want to find the whole vector of force 1, basically the first tugboat. I want to find the whole vector. How do I find that? Well, I do f of 1. I'm going to use this formula, but I'm gonna kind of rephrase it as it were. So I'm going to find f of 1, my vector of f. I should be saying that this is your magnitude. Sorry. This is your magnitude. So your first force of the tugboat, you're going to use your magnitude that they're giving you, so 1620. Sorry, I didn't put that in magnitude form up there. My apologies. And then I want to follow my formula, cosine of theta. Well, I now have a theta, right? So this is cosine of 120 degrees, I, and then plus sine of 120 degrees, and then j. So far, so good? This is the first tugboat. That's why I label it f of 1. So when I simplify all this out, and I'm just going to simplify it completely out for you. So find cosine of 120, find sine of 120, and then distribute that 620 in there. F of 1, what that equals is negative 810i, and then plus 1402.96j. So this is not my answer, but it's something that I'm going to be using to find my answer. Remember, I want the magnitude of the resultant force. I can't find that unless I find both of them equally. Okay? I can't find that unless I find both of them equally. Meaning I need to find both directional angles, both magnitudes, and put them in both, put both of them in vector form. So I have the vector form of the first one. That's awesome. So now let's go to my second one. That's the vector form of my first tugboat. Now let's go to my second tugboat, and then we need to find what is the directional angle first before I find the vector, right? So I'm given south 50 degrees west, so that's going to be in the third quadrant, not the second. So south, 50 degrees west, so this is west, and this is south, right? And this right here is 50 degrees. So if this is 50 degrees, what is, and this is what I want to find, my actual directional angle, what is all of this? That's what I want to find. So 90 plus 90 is 180 plus 40 more degrees, because this is 50, so that means this little area is 40. That's my reference angle. So 180 plus 40 degrees, that's going to be 220. So 220 is going to be my directional angle for my second tugboat. Okay? For my second tugboat. So far, guys, and I want to kind of put it together for you. So far, this is kind of what we've been doing. Notice how we were in quadrant 2 and quadrant 3. So let's just say this right here where this dot is, this is the ship that they're towing, okay? And I have a tugboat going this way, and I have a tugboat going this way. You feel me? So that's sort of what I've been saying. That's my basic picture at the very beginning of this question. That's what I kind of already kind of drew that. I have a tugboat going that way, and I have a tugboat going that way. So it's they're basically headed to America. They're both going, they're both going west, so they're headed towards America, but they're both tugging it kind of, so it slowly goes towards America. Okay? So that's kind of what we've been going through so far. Actually, I'll just leave that for reference. Now that I have my second directional angle for my second tugboat, I'm going to now use my formula to find f of 2. So f of 2, my actual vector for f of 2. What was my magnitude here? It was 1280. So I'm going to write 1280. And then times cosine of 220 degrees, and this is I, plus, and then sine of 220 degrees, and this is J. Okay? I know it's kind of weird looking. It's slow. My computer's being slow right now. As I did before, I'm just going to multiply all this out for the sake of time, but all you have to do is find 220, and if it's not on the unit circle, just calculate it yourself. You know, calculate what is 220 on the calculator. Make sure you're in degrees. Calculate sine of 220 on the calculator, and then distribute that through. Multiply it by 1280. That's all you need to do. What you get is, for your second vector, some big numbers here. You ready? So negative 980.54, and then I. Okay? That's what you get for the I. And then you get minus 822.77J. So 822.77J, but it's negative. So again, this is not my answer, but this is my vector, my second vector, that I'm going to use to find my answer, my resultant. So that brings me to the third step. You ready? I now want to find the resultant. So my third step, what is my resultant? How do I find it, for one? Well, all I have to do is just take f of 1 plus f of 2. So all I have to do is just take my two vectors that I found, that I put in vector form, when they just gave me bearings, the directional angle through bearings, and the magnitude. I found the vectors of both of them, and now I just need to add them. So this is going to get really complicated, but we can do it. So what's my resultant? So my resultant is negative 810 minus, and then 980.54 I. Okay, plus, and then I'm going to take my J, so I'm going to put in parentheses again. This is going to be 1402.96, and then minus 822.77J. Okay, so it's gonna, I know it's really crappy handwriting here. I'm really sorry. It's being really, really slow. But I'm gonna do all that. Sorry, I shouldn't put my J right there. I should put my J on the other side. I know it's being really slow, guys. This is taking up time on the video. I apologize. So it should be J out to the side here. Okay, so that's J. So that's what I'm doing. I'm taking my I, and then my I, and then my J, and then my J for both vectors, and I'm adding them, okay? So what do I get? I get a whopping, are you ready? Negative 11790.54. This is I, and then plus, when I subtract those two, I get 580.19J. This is, I'm going to call F just my straight up force. This is the total force that's happening, the total vector, the resultant vector. In other words, when both of them are happening, when I add them together, okay, when I add these two together, these vectors, this is like the total vector that's happening here, okay? That's sort of what's happening. And notice it is in quadrant 2, okay? So this is in quadrant 2, so that line right here should go a little bit up, but that's in quadrant 2. It's this side right here, the first tugboat, since it's obviously has more weight and it has a bigger magnitude, it's doing a little bit more work. So that's why you see that this vector, negative and then positive, that's going to be in quadrant 2. All right? Okay. That's still not my answer. What I need to now do is, now that I